Determine if the set of vectors is orthogonal and orthonormal. If the set is only orthogonal, normalize the vectors to produce an orthonormal set. Normalize means just make each vector a unit vector. Okay, so to check orthogonal, we multiply these two vectors. Let's say this is v1, second vector is v2, and if we take the dot product or inner product of these two vectors, what we get? Negative 2/3 times 1/3, negative 2/9 plus 1/3 times 2/3, 2/9 plus 2/3 times 0, 0, and this is negative 2/9 plus 9, 0. That implies v1, v2 forms an orthogonal. Okay, next we check whether they are orthonormal as well. So let's find the norm of v1, which is square root of, maybe let's find norm of v2, because the second one is easy. Just to check, we could have used v2, but let's find v1 and v2 as well. Negative 2/3 is squared, 1/3 is squared, 2/3 is squared, which is 4/9 plus 1/9 plus 4/9. That is 44819/9, which is 1, 1. That means v1 indeed is an unit vector. Okay, this is a unit vector. If this vector is also a unit vector, then they are orthonormal. Let's find magnitude of v2, norm of v2, which is 1/3 is squared plus 2/3 is squared, which is 5/9. That is root 5/3. So this is not an orthonormal set. They are orthogonal for sure because the inner product is 0. And one of the vectors is unit vector, but the problem is with v2. That's why I was trying to check this v2. Anyways, let's normalize. v1 is already normalized, so we need to normalize v2 to make orthonormal. So normalize v2. That means we multiply the vector by its divide each component by magnitude, or multiply this by 1 over v2 times the vector itself. Okay, let me write down here v2, which is we need to divide each entry by this magnitude. So 1/3 divided by, so let me write in this way then, 1/3 divided by root 5/3, 2/3 divided by root 5/3, 0 divided by this, just 0. This one is in fact 3 cancel, 1 over root 5, 3 cancel, 2 over root 5, 0. We can call this one normalizing v2. Let's call this one v2 2. Okay, v2 2. So this vector and v1 forms an orthonormal set. Thus v1 v2 2 is an orthogonal as well as orthonormal. Okay, orthogonal in the sense if we multiply v1 and v22, the product is 0.